So again, thank you. This is the National Academy building on Constitution Avenue. And we were commissioned, I say we, myself and my lab, which is the Imaging Research Center up at UMBC, as JD said, to build an iPad app or some interactive technology that we could give visitors to this building in order to help them understand some things about it. So the commission comes from this man. You may recognize him. Love that picture of him. I just had to share. Oh, sorry. Just had to share that. We were asked to create an iPad app for visitors with the goal of helping them understand the iconography of this fabulous dome. If you haven't seen it, you must. 2100 Constitution Avenue. And this was designed by Hildreth Meière in 1924 to inform, in a way, the public about a view of science at that time. So that was one of the goals of the technology we were to create. And the other, which was a second phase that we're in now, is to create a new interactive layer of the app to say something about science since 1924. So there's sort of a pre-1924 and a post-1924 aspect to this. What's interesting is this space has no Wi-Fi and no GPS, and no, we can't use audio there, and there's no cellular. And iPads, which is, you know, the goal was to give visitors, when they walked in the door, an iPad or something like it, have very little storage and memory. So if we couldn't stream through Wi-Fi, we're somewhat restricted in terms of what we can put on there in terms of material, which is the kind of challenge that the programmers and artists in my lab like, actually. We decided, I'm not going to, we also are building a website. We built a website. We're now upgrading the website. I'm not going to talk about that tonight, just the app, really. We decided on a kind of augmented reality app for the iPad, something experiential that viewers could quickly get an experience with. We wanted viewers to feel that they could touch the top of this dome, which is 60 feet off the floor of the main gallery of the Great Hall. We wanted to essentially build the app, build the dome in the app. And we also wanted people to be able to download it off the iTunes or off the App Store so that they could recreate being in this space in their living room or in their office. So we started by photographing the dome. This is the director of our lab, Dan Bailey, and his son. Dan is a brilliant panoramic photographer, so took lots of little pictures of that dome and then stitched them all together. Now I'm going to go to the app and hope that things hold together. Okay. So this is that first part that I described to you, where you are able to make sure I don't yank their technology apart. That would be so unkind. There we go. Yeah, so the compass in the new iPad 2 Air is not as reliable as the old ones, unfortunately. But on a good day, this is aligned with the compass point. We used compass. I don't want to get anybody sick here. I better be steady. We aligned it with the compass so that north is north and so on. And this orients to the ceiling. And you can see we've changed the coloration of the ceiling so that people know what to click on, etc. I'm going to set this down and turn off the compass. It works with swipe technology too. The hard thing about getting the compass and accelerometer to work together and hand everything off was that they don't really like to. You can zoom in and really touch the dome. That was our goal. You can also learn way more than you wanted to about all of these traditional academic disciplines, which is what these 8 icons that you're looking at right now are. Of course, you can learn about NAS and building, etc. So that's the first phase, the pre-1924. It's kind of like Augmented reality meets wall text in a way, but it's very quick and efficient for people to get a lot of information. But to talk about what happened to science since 1924, rather than just make it up, which would have been a lot of fun, we decided to, well, we worked with NAS, who were very gracious about connecting us with 12 top minds in science in the US. And JD and I flew around and interviewed them last spring and summer. We developed an ethnographic survey, really. So I'm just going to tell you briefly who they are. Cynthia Bell she figured out that the human metabolism is affected by culture, which I just find to be an astounding thing, isn't it, really? You can read their titles, but I'm going to tell you something more interesting about them. James Gates is at University of Maryland, and he's perhaps the originator of superstring theory. Neil Gershenfeld sees matter and information as the same thing, and he's the founder of the Fab Labs, of which there are more than 400 around the world now. Kurt Johnson is the new director of the National Museum of Natural History, accomplished geologist. If you watch Charlie Rose, Eric Kandel is the neuroscientist that you would probably be hearing from. He figured out how a single brain cell remembers things. Robert Lefkowitz found the G protein receptor in your cells, and that's why your antihistamines and beta blockers work, so we should be really happy about what he's done. And then Mark Rothenberg is a historian at the National Science Foundation, terrific guy. And Barbara Shaw was the former vice president of the National Academy of Sciences, and she's on the President's Council of Science Advisors. Eugenie Scott may be single-handedly responsible for the fact that we can teach evolution in Texas and other places. Manil Suri is just a guy with a great scope. He's an applied mathematician and a New York Times best-selling novelist. Craig Venter, who probably many of you know, he sequenced the first human genome. He synthesized the first genome, and if you go online to get free open source DNA, it's his. George Whitesides is a chemist who has turned a medical lab into a little chip of paper that can be distributed throughout the world where there's great need. So I'm going to play a total of 3 minutes worth of very short, almost random clips that give you a sampling of the kinds of things the scientists said. And I will give you a preview of the second phase. A lot of what we're doing is featuring the scientists themselves so that you're hearing about science in the voices of the people who are most accomplished at science. Here's a little bit. Oh, wait a minute. Of course. It's not coming out the right hole. We may be skipping this part. Whoops. We tried this. It worked beautifully a few minutes ago. Let me unplug and try it again. That worked last time.
The terms for the different disciplines
No.
are imaginary. They're made up by people. They never made any sense. They never will make any sense.
Did you
Oh, that's an idea. I'll hold it near the mic. Brilliant. So high tech. Okay, here we go.
The terms for the different disciplines
Can you hear it?
are imaginary. They're made up by people. They never made any sense. They never will make any sense.
The problems that we need to solve, both intellectual problems like what is life, and practical problems like how do you run a mega city, a city of 50 million people? How do you do that? There is no discipline that actually covers those subjects as a single subject.
I just figured out why this isn't coming out the right hole. Watch this. I'm going to plug it in just to see what that's like. No, I forgot. We don't send it out to VGA. Anyway, all right, let's see. See if this works better.
My personal perspective is that science is one way of what I like to call myth-making. But in our telling of the story, we also then demand that each new generation of listeners come and try to falsify the story.
what science does really well is to describe the natural world. But what science doesn't do very well is to help us understand how that impacts our human world, how it impacts our culture, and how it impacts our society.
The science is necessary, but not sufficient for making these kinds of cultural decisions.
Scientists have not been very convincing at helping the public understand how science works.
And many scientists of my generation at the beginning of my career thought it was bad taste to try to communicate to the general public.
Science has to step out of the bounds of science and enter the realm of humanities and arts so that scientists are aware of who they're communicating with.
The large-scale question, I mean the deep question in all of brain science is the nature of consciousness.
If the genetic code is so core to everything human, how can we practice medicine without understanding that core?
You advance by crossing boundaries, by bringing together fields. The real challenge is how you educate scientists to be able to do this.
Science, at least as practice in the U.S., is or has become risk-averse.
Many people are confused, I believe, about the essential nature of science. They think science is what you find in a science book. And what I like to tell people is that's like walking into the studio of a great sculptor, looking down at the floor and seeing a lot of pebbles, walking out of the room and concluding that what sculptors do is create little pebbles.
Not all, but most scientific research is very chaotic and also involves a lot of play.
Good science comes down to one very, very simple human attribute: curiosity. It's that simple.
Somewhat sobering is the understanding that we now have from genetics that our behavior, our lifestyle now as adults can influence the health and the biology of our children and even our grandchildren.
So it was really fun to interview them. You can imagine there's 85 clips that you'll be able to see online, and a lot of that information will be in the app as well. But they had really interesting things to say, and they weren't afraid to say powerful things that really shake things up, I think, in a lot of ways. And a lot of what they talked about was about the context of science in a lot of ways. Instead of just talking about their individual disciplines and how those have progressed, although we asked them those questions, they're often concerned about the larger questions of science itself. We analyzed the data using a pretty ethnographic procedure and came up with the categories that you previously saw. So to sort of characterize what we took away from what they said the disciplines are breaking up, constantly changing, the domain of academia only, perhaps irrelevant. They said science is just one way of knowing and a misunderstood one. It's not a belief system, but a method of thought. They said science has a difficult relationship with society that should be addressed outside of science. They said the grand challenges and mysteries range from understanding consciousness and the implications of genomics for medicine to getting scientists and the enterprise of science to take more risks. On being a scientist, they said that they want us to know it's fantastically interesting and a deeply human endeavor, but one with limits. Though amazing to be sure, they said the accomplishments of science also cause us to rethink and expand our vision of who we are. What I think, as an artist, one of my bigger takeaways was that science is different than people think. And though this is a work in progress, I'll try to show you where we're going to try to get at this. So if you hold the app up, you'll see there's a spinning blue ball there in the center. I'm going to turn off the compass and just swipe over there. That blue ball is not in the building itself. It's in our app. And this is what happens when you tap it. So what we hope is in that short animation that you're getting a very different sense of science than you might get by looking at the nice pat icons that are arranged around the center of the 1924 painting, as much as we love that painting. The disciplines come and go. You can tap on disciplines and see which ones they birthed. It's a living, breathing, organic kind of a world that we're trying to create. And by moving around the world, which again, you know, you're in your office and you're seeing a world that, let me get back to the mic, you're seeing a world that is not pat and not organized and not taxonomic, and where all the problems have not been solved. You're also seeing scientists every time you click on one of these red squares. I think we ended up with red squares because the programmer who did this is Russian. But we're gonna go with a different schematic on that. I like kind of just ending up in a place. You know, a lot of what you see going on is created randomly, algorithmically. We push the iPad to its limits in terms of the amount of graphic richness that it could create at any given time. Not all of it is. Some of it is bitmap, some of it is pictures. But you can see whizzing by at the equator, you can see these photons that are behaving like waves. They move at different speeds depending on what color they are, because colors have different frequencies. Lost in space here, but actually all around this app, are tiny little floating particles moving in Brownian motion, which is the way particles move in a fluid when they bump into other atoms in the fluid. And Craig Venter remarked that he thought that was the biggest mystery of science. It's what creates all the interactions inside cells. We have cells sort of drifting, again, in Brownian motion, unidentified. We have subatomic particles in slow motion. If you could take the CERN super collider and slow it way down, you might see something like this. These particles start off with one trajectory, but then they're affected by gravity points that we've placed around this world, and they begin to interact with one another and sometimes get into these little orbiting stories. And you know, the thing about this app is it's never the same twice. This is really a completely fresh experience in a way each time. The interviews, the excerpts that you're seeing with the scientists are organized longitudinally by sector, by category. So that's a little obscure, we understand that, but that's, you know, how we've put 85 excerpts with really interesting messages from these different scientists. I think that overall, here, I'll see if I can park somewhere interesting while I make a couple final remarks. I think that overall, when we look at art and science together, certainly my interest as an artist and our lab as well, we're very interested in how artists can complement science. So we've sort of brought the full load of art stuff here. You know, a lot of these decisions are intuitive. A lot of it's ambiguous. We're using metaphor and analogy. We're trying to create an aesthetic experience. We're not explaining to people everything that is happening to them. There's no kind of map of supposed tos. So we're trying to put people, at the same time, this is sort of an artistic expression, we're trying to put people kind of in the same position that scientists are. And the scientists that we interviewed had very, very interesting things to say about the difference between science education and being a scientist, and we wanted to try to capture that. So, in closing, this is my team, only part of them, and I thank them because they're so talented. Thank you so much.